Hi everyone, welcome back. We're up to lesson 11 of unit 2. In this case, we're going to learn how to find the points of intersection of two polynomials without graphing. And the steps to do that are right here. So we're going to convert both polynomials to standard form if necessary. Sometimes they might be in standard form already, so if you have to, convert it. If you don't, if it's already in standard form, you don't have to worry about that step. Step 2 is you're going to set both polynomials equal to each other. Step 3, you're going to solve for x. Okay? And I put in here that you sometimes might end up with a quadratic equation. So if you remember, when we're solving quadratics, we can solve by factoring. We could also use the quadratic formula. All right, so if you do end up with a quadratic equation, you can solve it either of those two ways. Once you get your x values, because we're finding points of intersection, points, remember, have x values and y values. So once you find your x values, you need to plug those into one of the original polynomials to find the y values, and that will give you your complete points. So let's look at my example here. Find the points at which the graphs of the following polynomial functions intersect. So notice these are both in factored form. So the first thing I have to do is I have to convert these to standard form by using the box method. So let me set that up. So x plus 4, x minus 8, and then x minus 8, and 2 minus x. All right, so let's do this first one here. X times x is going to be x squared. Negative 8 times x is going to be negative 8x. 4 times x is going to be 4x. And negative 8 times 4 is going to be negative 32. So if we put everything together, starting with x squared, we end up with x squared. Negative 8 and a positive 4x is going to give me a negative 4x minus 32. On this side, I have 2 times x, that's 2x. 2 times negative 8 is negative 16. Negative x times x is going to be a negative x squared. And negative x times negative 8, that's a negative times a negative, so that's going to be a positive 8x. And if we put this together, again, I'm going to start with my x squared term down here this time, so that's going to be negative x squared. And then I have 8x and 2x is 10x. And then minus 16. So I put them in standard form. Now I can set them equal to each other. So you can see I'm going to end up with a quadratic, so I have to make it so that it says equal 0 on one side. So to do that, I'm first going to add x squared to both sides. Okay. I'm going to subtract 10x from both sides. And then I'm going to add 16 to both sides. If I do that, I end up with equal 0 on the right-hand side. So I put this together, x squared plus x squared, that's going to be 2x squared. Negative 4x and negative 10x, that's going to be a negative 14x. And negative 32 plus 16, that's going to be a negative 16. So I have 2x squared minus 14x minus 16 equals 0. So that's the equation I solved. The thing I notice is that all of the terms in this equation, 2x squared negative 14x, negative 16, and 0 even, those are all even numbers. And we know that even numbers are divisible by 2. So what I'm going to do to make things easier is I'm actually going to take every term and I'm going to divide every term by 2. Okay? As long as I do that to every single term, then I'm okay. So 2x squared divided by 2 is just going to be x squared. Negative 14x divided by 2 is going to be negative 7x. And negative 16 divided by 2 is going to be negative 8. And obviously 0 divided by 2 is 0. So now I'm down to x squared minus 7x minus 8 equals 0. By doing that, now I can actually try and factor. So remember, with factoring, I need to figure out two numbers that when I add those two numbers, I get negative 7. And when I multiply those same two numbers, I get negative 8. So two numbers that add up to negative 7 and multiply to negative 8, those two numbers are going to be negative 8 and positive 1. All right? Negative 8 plus 1 is equal to negative 7, and negative 8 times 1 is equal to negative 8, which means my factors are going to be x minus 8 and x plus 1. So now I can set each of these equal to 0, which means here, if I use that switching sign trick, x is going to be equal to 8, and x is going to be equal to negative 1. Okay? So I solved for x. Now I have to pick one of the two original polynomials. So I'm just going to pick the first one here. So x plus 4, x minus 8, and x plus 4, and x minus 8. So now I'm going to pick one of those polynomials, and I need to plug in both x values to get the corresponding y value. So that's going to look something like this. So I'm going to plug in 8 for x, and I'm going to plug in negative 1 for x. If I plug in 8, I end up with 8 plus 4 is 12. 8 minus 8 is 0. So this is really 12 times 0. So that's going to be 0. This one, negative 1 plus 4, that's going to be 3. And then negative 1 minus 8. Negative 1 minus 8 is going to be negative 9. Right? Negative 1 minus 8 is negative 9. And 3 times negative 9 is negative 27. Okay, so I found the y value. So to answer the question, the points of intersection are going to be 8, comma 0, right? X equals 8, y equals 0, and negative 1, comma negative 27. Those are my 2 points of intersection, and that is it for this lesson.